Okay. Thank you. I am Dr. Manjeet, working as an assistant professor in Government College, Safidon. Firstly, I would like to thank Magnus Group, all the organizing committee, to give me second chance to present my research work. And today, I am going to present my research work entitled Assessment Suitability of Fish Culture in Paddy Fields, Growth Performance of Channa, punctatus, and Paddy Yield. Channa punctatus, spotted snake-headed fish, is highly priced freshwater food fish species in India. It has a great demand in market because of its high nutritive value. It is a hardy fish and can tolerate varying physicochemical characteristics, including low dissolved oxygen, and thus it is a preferred species for rice-cum fish culture. It has a great demand in market because of its high nutritive value. And if we are talking about rice and fish, rice acts as a nitrogen sink and help to reduce the ammonia released by the fish and make the water cleaner. And excretion of fish could be considered as a good source of fertilizer for the rice. In this scenario, the integration of rice and fish production is an efficient mean for agricultural land use and offer great potential in terms of animal protein supply, income generation by double utilization of land for small scale farmers. And in India, export approximately 5.2 lakh tons of fisheries worth rupees 8,363 crore per year. Now, the objectives to study the ecology of paddy cum fish culture fields, to study the growth performance of fish in paddy cum fish culture field with and without supplementary feed, to study the economics of rice monoculture, rice cum fish culture, and fish aid with supplementary feed. Now, material and method. 12 paddy plots of 120 square meter area were selected at village Pipalthar district, Jind, Haryana in India. And we selected the fish Channa punctatus, that is a carnivorous air breather, hardy fish and tolerate low oxygen level. And the studies were conducted in 5 treatments. Treatment 1, 2, 3, 4, and 5. In all these treatments, in treatment 1, rice monoculture. In treatment 2, rice culture with fish, organic farming. Treatment 3, fish in rice field with recommended doses of pesticide. And treatment 4, rice in fish in rice fields with exposure whatever the pesticide doses used by the farmer. And in treatment 5, that is called the farmer's treatment, rice field with fish, without fish but pesticide exposure according to the farmers. Now, in case of rice cum fish culture, firstly we have to prepare the rice field. And all these methods like cleaning of weed, we made fish refuges, we installed the screens, fertilized the field with cow dung, we made the embankment, inlet and outlet, trenches were made. And these are the picture while we are preparing our rice field for the rice cum fish culture. And the farmer harvesting the fish before 10 days before the rice harvesting. And firstly, we study the ecology of paddy cum fish culture fields. Is it suitable? Is it like pH, turbidity, conductivity, dissolved oxygen, all these physicochemical parameters, their limits. Is it congenial for the culture of fish in rice fields? We did all these experiments, we did all these tests by using APHA 1998 and followed by the method Garg et al. 2002. Growth monitoring, we followed all these methods given by Garg et al. 2002. Statistical analysis, all assays were performed in triplicate and data were represented as mean plus minus standard error of mean for 3 sets of these experimental subgroups. Significant differences among treatment group have been tested using ANOVA, followed by Duncan multiple range test for the experiments. Now, ecology of rice field. We studied the ecology in case we check all these parameters like pH, like dissolved oxygen, and the limits of all these parameters are congenial for the culture of fish in rice fields. These are the phytoplankton. Phyto and zooplanktons were developed in sufficient amount for the initial stages of the fish like fries and fingerlings. We did all these experiments. We took the water sample at fortnightly intervals, like day 2nd, day 15, day 30th, day 45th, day 60th, day 75. And this graph showing the same. These are the beautiful picture captured under the microscope. The family of Chlorophyceae, Microspora species, Ulothrix, Spirogyra, Clostridium species, and Navicula, Nidium, Pinularia. These are the phytoplanktons and euplankton species in water sampling during fortnightly intervals and captured under the microscope. Now, growth performance of Channa punctatus without supplementary feed. These are the parameters we observe. The initial weight, that is approximately 15 gram. And the final weight is 62 in treatment 2, 59 in treatment 3, where recommended doses of pesticide. All these treatment in which the fish were reared without the supplementary feed. And the weight gain in treatment 2, that was 46 gram. In treatment 2, 43 in treatment 3, 37 in treatment 4. The length were observed in all these treatment without supplementary feed. That is the approximate composition of fish without supplementary feed, and crude protein was observed 14.8 in treatment 2 where no pesticides were observed, and 14.4 in treatment 3 where recommended doses of pesticides were sprayed. And these protein values were observed in the fishes without supplementary feed. And we already calculated the economics of rice cum fish culture fields without supplementary feed, and total revenue from rice and fish were observed maximum in treatment 3rd with recommended doses of pesticides without supplementary feed. The graph showing the rice yield per hectare in all these treatment, and clearly visible in treatment 3rd, maximum rice yield were observed. Now, in our experiment, evaluation of growth performance of Channa punctatus in paddy cum fish culture field with supplementary feed. Same ecology of rice fields were done, and all these parameters were carried out, and the limits of all these parameters are congenial for the growth of the fish. Now, if we compare about the final weight without supplementary feed and with supplementary feed, that was approximately 62 gram, and with supplementary feed it is 115 gram in treatment 2, 108 gram approximately in treatment 3rd, and 90 gram in treatment 4. Growth percent gain in body weight is also maximum in treatment 2 without pesticide exposure and with the supplementary feed. The picture showing the same length was observed maximum in treatment 2. Now, the approximate composition of the fish. Maximum crude protein percentage was observed in treatment 2, that was 15%. And this graph elucidate the rice yield per hectare, also showing the same in treatment third with recommended doses of pesticides. In case of rice yield, there was no significant difference were observed with and without supplementary feed. But in case of fish yield, a significant difference were observed with and without supplementary feed. The maximum yield was observed with supplementary feed, clearly visible in the graph. Now, the economics of rice cum fish culture field with supplementary feed and total revenue from rice and fish were observed maximum in as compared to without supplementary feed. Significance: the rice and fish culture will be helpful in generating more food resources from the same piece of the land, leading to sustainable food security. The water of rice field can be utilized for fish production, will also helpful in increasing rice production. Rice cum fish culture have less weed and pest because fish consume some of the weed and pest of the rice field. Economics of fish culture also depict increase in total profit. And at the same time, excretion by fish adds nutrient to the soil. Fish excrete ammonia and movement of the fish enhances the circulation of the nutrient in integrated rice fish culture, leading to higher rice yield as compared to mono rice culture. Thank you.